Hey guys, this is Mrs. Harbin and this is Algebra 1, Section 2.6. Our life application for this chapter is this. In order to understand and solve for the unknown, the student must build on a firm mathematical foundation. Just as in his daily life, he must seek to be a spiritual judge who subjects all things to the scriptures to discern what is right and wrong. We face a lot of unknowns in life, whether we're talking about our real lives, our spiritual lives, where we don't know how a decision is going to go or how things are going to turn out. And we've got to solve problems sometimes to figure out that unknown. And we want that foundation to be in the scriptures. In math, we're solving for the unknown all the time. We're trying to find the variable that's missing. We're trying to find missing information. And we've got to use the foundational pieces of math to find that information. And that's what we're going to take a look at today. Our lesson objective for today is this. You, the student, will solve equations containing like terms and parentheses, translate word sentences into algebraic equations, then solve. When simplifying equations, we can use the distributive property to do two things. First, it can remove parentheses, and second, it can help us to combine like terms. In order for an equation to be completely simplified, we can't have any parentheses left in that equation. And the distributive property is the primary way that we're going to remove those parentheses in our lesson today. Let's take a look at this equation. 3x plus 2 plus 5x minus 7 equals 28. We want to simplify each side of the equation one side at a time. Now on this side, we have just a 28. Just a number. There's nothing else that we can do to simplify that. So we're going to look over here at the left side of our equation. And the first thing we want to do is see if there are any like terms that we can combine. Now remember, a term is either a number, a variable, or the product of a number and a variable. In this equation, we have 1, 2, 3, 4. 4 terms. Terms are separated by addition and subtraction signs. So you can see that there are 4 terms. This one is a number and a variable, the product of a number and a variable. This one's just a number. This one is the product of a number and a variable. And this one is also just a number. So when we're looking to see what terms we can combine, we see that we can combine the 3x and the positive 5x. And we can combine those because they both have the same variable being raised to the same exponent. They both have x to the first power. We can also combine 2 and negative 7 because they are also like terms. When we combine 3x and 5x, we get 8x. And 2 and negative 7 gives us negative 5. And that equals 28 stays the same. We haven't done anything with the right side of the equation. Now, our goal is to get this 8x by itself, which means we have to remove this 5x or negative 5x. And the way that we cancel something or get rid of something is by doing the opposite operation. We know that to cancel negative 5, a positive 5 will cancel that out. Negative 5 plus 5 equals 0. So that will leave us with just 8x on that side. But because these things are equal, one side is equal to the other, in order to keep them equal, what we do to one side we have to do to the other. So if we add a 5 here to cancel that negative 5, we've got to do plus 5 over here to keep it balanced, or to keep the two sides equal. Once we do that, we get 8x equals 33. Now, the 8 is being multiplied by the x. Remember, a number and a variable right next to each other, that means the implied operation is multiplication. We need to get rid of that 8. And the way that we get rid of 8 times something is dividing by 8. So we're going to use a fraction bar here to represent division. We know that 8 divided by 8 is just 1. So those will cancel each other out and leave us with 1x. But because this is an equation and the two sides are equal, we've got to keep things equal and do the same thing to both sides. So if we divide this side by 8, we've got to divide this side by 8. And when we do, we get x equals 33 over 8. We're going to keep that as an improper fraction. We're not really going to switch anything to mixed numbers anymore at this point in our math careers unless we're solving some kind of real-world problem where it asks us for mixed numbers. We're also not going to switch it to decimals unless it's asking us for, again, real-world information that we need to have in decimal form. Other than that, unless we're asked for mixed numbers or decimals, we're going to leave our answers from this point forward, Algebra 1 forward, as improper fractions. Let's take a look at another example. You can see here that we have some parentheses, and hopefully you remember the way that we get rid of parentheses is the distributive property. So we can distribute that 3 and multiply it by x and 1. And don't forget that there's a negative 1 here that we can also distribute to get rid of these parentheses. We can't just drop the parentheses. They're there for a reason. We need to distribute. When we do that, we get 3x plus 3 minus x plus 2 equals 13. Now this side is already simplified, so we're going to leave it alone. We do have some things over here, though, that we can simplify. If you take a look at our terms, we have 4 terms yet again, separated with plus and minus signs. We've got a 3x and an x, so 2 variable terms, 3 and a 2. So we've got 2 x terms and 2 integer terms. We're going to combine that 3x and that negative x to get positive 2x, and a positive 3 and a positive 2 combines to be positive 5. Hopefully you remember how we're going to get that 2x alone. We need to get rid of this positive 5, and we're going to do that with inverse operations. Subtract 5, and if we subtract 5 from here, in order to keep our two sides equal, we've got to subtract 5 from here as well. That gives us 2x equals 8. We need to separate this 2 times x, and the way that we get rid of or undo the multiplication operation is division. So we're going to divide both sides by 2. Again, doing it to both sides to keep the sides equal, we find out that x equals 4. If we're not sure if that's the correct answer, all we would have to do is go back in and evaluate this equation at x equals 4, which means plug and chug that 4 in and see if you get 13 equals 13. You should, and you do, and that means it's a true statement. Now let's take a look at some word problems and translate these into equations and see if we can figure out how to solve them. John's mother is 4 times as old as John, and John's brother is twice as old as John. If you find the sum of their ages and add 3, you get 80. What are the ages of all 3 people? Well, the person whose age that we don't know is John's age, so that's going to be our variable. Everything else is just a reference to John's age. John's mother is 4 times as old as John, and John's mother is twice as old as John. So everything is dependent on John's age. We also know that we're going to have to add something together here to find the sum of their ages. And we're also going to have to add 3 to that sum. And we know that when we've done all that, we're going to get 80. So how can we set this up? Well, let's make x John's age. John's mother's age is 4 times as old as John, so 4 times John's age. And John's brother's age is 2 times John's age. It says if we find the sum of their ages and add 3, we get 80. So let's add these 3 things together. John's age, and John's mother's age, and John's brother's age, and 3 more, it tells us. When we add all that together, we get 80. From here on out, we're going to combine like terms, and we get 7x plus 3 equals 80. We're going to work to isolate our variable, and we do that with inverse operations, which gets us to x equals 11. That's John's age. So how do we find John's mother's age and John's brother's age? You said plug and chug and evaluate. You are right. John's mother's age is 4 times that, and John's brother's age is 2 times that number, which gives us 44 and 22. Let's take a look at this one. Express 0.36 repeating as a quotient of integers. Quotient, if you remember, is a division fact. So if you remember earlier, I said we're going to leave our improper fractions, like 22 over 7, leave those as improper fractions. So leave them as quotients, a quotient of integers. Now we're being given a decimal, and we're being asked to change that back to a quotient of integers. We first set the decimal equal to the x. So x equals 0.36 repeating. Multiply by a power of 10 with the same number of zeros as the repeated decimal. Multiply by a power of 10 with the same number of zeros as the repeated decimal. So we're going to multiply by 100 here. This went to the hundredths place, which is why we multiplied by 100, and we're going to do that again to both sides. Why? Because an equation is equal. It's balanced. We've got to keep the two sides the same. We'll subtract the value of x from both sides. X is 0.36 repeating. We know that because of this step right here. And we get 99x equals 36. Solving for that, we get x equals 36 over 99, which simplifies to 4 over 11. Express 1.36 as a quotient of integers. We're going to multiply by 10, subtract our x. We get 9x equals 12.3. Divide that by 9 and simplify, you get 41 over 30. Today we solved equations containing like terms and parentheses. We translated word sentences into algebraic equations and solved them. And we converted repeating decimals to fractions. If you guys have any questions, be sure to ask me next class.